There's a story about Yuri Shimatari, a fisherman who rescued a turtle. As a reward, he was taken to the palace of a dragon god by the turtle's mother. However, when Urashima returned to his hometown in Japan, 300 years had passed instead of just 3 days, as he realized. This is one of the earliest recorded time travel stories in history, and it's not the only one. The idea that time may not be as solid as it seems in our daily lives has appeared in various cultures. So, it's worth asking, is time travel possible? The answer is yes. We know for certain that time travel is possible. In fact, there are time travelers among us. For example, Russian astronaut Sergei traveled 0.02 seconds into the future. That's a very short leap compared to the fisherman's 300-year journey into the future, but it's the same concept on different scales. But before we delve into time travel, let me share a tip that applies to the present, past, and future. You know that desire to learn something new that can completely change your life? Well, can you travel to the future? Is it possible? The answer is yes. Traveling to the future is possible, and it has already been achieved. And perhaps traveling to the past is also possible. According to Albert Einstein's theory of relativity, the central aspects of time travel are intertwined with space and time. They are one and the same. Just as a car can brake and accelerate, changing its speed in space, there are ways to change your speed in time. And one of them is through your own velocity. The closer you move to the speed of light, the slower time passes for you. And nothing can be faster than light. For example, if you spend 3 days in a spaceship traveling very close to the speed of light, you will exit the ship 77 billion kilometers from your starting point and 300 years into the future. The ship moved through space, but it also moved through time, reminiscent of the legend of Urashima. And it's not just high speeds that can change your position in time. The force of gravity is nothing more than warped space-time. Anything with mass changes and curved space-time. It is certainly possible to build a time machine to the future based on strong gravitational fields. Going back to the past is more complicated, but using high speeds and gravity in the right way, it might be possible. However, let's clarify something. When we talk about traveling through time, it's more accurate to say taking a trip around time rather than going back in time. Let's imagine you leave your house and start walking east in a perfectly straight line. If you go far enough, you will circle the planet and return to your starting point, even though you've always been moving in a straight line. You completed a circle. The curve is not in your movement, but rather in the surface of the Earth. Creating a time machine to the past is similar. We need to find a configuration of matter that bends time in a closed loop, creating a closed curve in time, just as traveling in a closed curve in space allows you to return to your starting point. Now, if you travel in a closed curve in time, you can complete your journey before you even started. You have taken a trip around time and returned to the past. As a consequence, you could even meet your past self and say hi to them. Hi, past Pedro. I just took a trip around time. Funny thing is, I was leaving home to do the exact same thing. I know you, past Pedro, didn't leave home, so it's possible to create a closed curve in space. However, we need to discover certain things we still don't know. The simplest way to create a realistic time machine would be to use wormholes. Wormholes are hypothetical astronomical objects that connect two places in space through an alternate path. Visually, it's like the handle of a cup. The important thing is that you enter through one end of the wormhole and exit through another hole, located elsewhere in space-time. To turn this into a time machine, you would need to take one of the wormhole exits and move at extremely high speeds. Just as moving at high speeds makes time pass differently, one of the exits of the time machine would be in the past relative to the other. Does that make sense? So you could enter one end of the wormhole and come out in your own past. And here's an important note, This machine wouldn't allow you to travel to a time before the machine was created. All time machines based on the theory of relativity divide the history of the universe into two parts, before and after the time machine. It is only possible to travel between the past and the future once the time machine exists. This actually answers one of the paradoxes of time travel. Why haven't future time travelers visited our present? It's because you can only travel to points in history where a time machine already exists. In other words, we will only be able to meet time travelers if we create a time machine. There are other paradoxes that complicate the idea of time travel, the most famous being the grandfather paradox. If you go back in time and prevent your grandparents from meeting, as a result, your parents would never have existed, and neither would you. But if you don't exist, you can't go back in time and prevent your grandparents from meeting. However, if that were the case, your grandparents would have met, your parents would exist, and so would you. So it's possible to go back in time and prevent your own existence. The loop of this paradox repeats itself. There are three ways to solve this paradox. The first solution is the principle of self-consistency. Time travelers already make history in a consistent way. In other words, if your grandparents met, it's impossible to change that fact by traveling back in time. The principle of self-consistency states that it's impossible to change the present through the past, and any change is already accounted for in history. A simplified version of this has already been proven with a game of billiards, where balls can travel back in time. There's always a story that makes sense, no matter how strange the ball's trajectory may be. The second solution to the grandfather paradox is that time travel creates parallel realities. If you go back in time and prevent your own birth, two alternative realities will exist, one where you exist and traveled back in time, and another where you don't exist and couldn't travel back in time. The third solution is simple: time travel is impossible. This is actually the position of physicist Stephen Hawking in his chronology protection conjecture. Just imagine you have a time machine, a closed curve in time, and a single light particle entering this tunnel through time. When the particle completes a loop, it encounters itself entering the time machine. So, there are two particles inside the time machine. Using the same logic, those two particles will meet again as they complete their journey through time. Therefore, we have four particles. But following this logic, there would be 8, then 16, 32, 64, and so on. This creates an infinite loop, implying the existence of an infinite number of light particles inside. This scenario violates the principle of conservation of energy and leads to inconsistencies in the fabric of space-time. Therefore, according to the chronology protection conjecture, the laws of physics prevent the existence of time loops or closed curves in space-time. While the concept of time travel remains an intriguing topic in science fiction and theoretical physics, there is currently no scientific consensus on its feasibility or practicality. Many theories and ideas have been proposed, such as wormholes, black holes, and cosmic strings, but they are all highly speculative and require advanced technological capabilities that are currently beyond our reach. It's important to note that even if time travel were to become possible in the future, it would likely come with significant limitations and restrictions. The complexities and potential paradoxes associated with altering the past or creating multiple timelines make it a challenging concept to navigate. For now, time travel remains a fascinating subject for exploration in literature, movies, and scientific thought experiments. Scientists continue to study the nature of time and delve into the mysteries of the universe, but conclusive evidence or practical applications of time travel are yet to be discovered. If you have any more questions or if there's anything else I can assist you with, feel free to ask.